Good afternoon, students. How are you all? Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. This is Suresh, Faculty of Chemistry from Infinity Learn. How are you all, dear my students? Great to see. Yes, can you please confirm whether I'm audible or you can see me on the camera? Welcome to NEET STEP UP 2025 program on YouTube platform provided by Infinity Learn by Sri Chaitanya. In this platform, we are offering physics, chemistry and biology sessions right from 12 o'clock to evening 6 o'clock and regular basis Monday to Saturday. So please students, you just make use of these students, get benefit out of it, and you like these sessions and share with your friends and subscribe. Ishita, good afternoon. Good afternoon, Ishita. So you don't have a school today? Yes. So nowadays Richa Sharma is going to school, not seen in the chat box. Okay, those students who are not chatting, you just try to come on chat box and you can ask your a number of doubts so that we can have an interactive session, right? Great to see. Okay. Right, today's class is all about second part of thermodynamics. So we started thermodynamics. In the first part, we have seen all the basic terminologies. And in the second part, my agenda is going to be, let us talk about work, heat, and the first law of thermodynamics, various forms of first law of thermodynamics in various processes. And also we are going to eventually going to heat capacity, molar heat capacities and entropy and related to some thermodynamic operations and their numericals. Those numericals and logics that I apply in this class are absolutely useful for your NEET examination kind of preparation. This is a physical chemistry part, so that you need to do a lot more in the concept and their mathematical approach. It's almost like physics, right? And you apply logical questions and NEET examination. Are you ready? Are you ready? Yes. Before going into the details of thermodynamics, I got something for you. Why? These sessions we are providing is absolutely useful for those students preparing for NEET 2025 and those who dropped in 2024 NEET examination. So let us take a relative marks increment with those students who secured very good score with respect to 2023. If you just see, Ashrita, she got 310 in 2023 examination and she got 2024 में 661 बन गया. So that there is an increment of 351 marks. It's a very good decision she has taken. And Akhil Verma, he got only 313 in 2023 and got 658 in 2024. So you can see 345 marks बढ़ गया इनका. And Himadhyuti, she got 310 marks. Ishita, yes, she got 652 in 2024. You can see 342 marks बढ़ गया. Those students are from Infinity Learn and I personally taught them, right, on Infinity Learn Meta app, Infinity Learn ground में. Okay, they are taken online coaching with Infinity Learn. They got, you can see, Satyanarayanan and 330 and he scored 650 in 2024, 320. So कम से कम 300 plus marks को बढ़ने का कोशिश करो. And hundreds of students are there in our various batches of NEET prepared 2024 का, and 2025 में you will be the next, I can assure you that. Yes or no? Yes, that's good. So ऐसे मत सोचना. So you just think, you take a drop in 2024 and 2025 you can prepare it, and lot enough, 8 months, enough time. We are going to finish 11th and 12th syllabus in various courses. You can enroll even, and you can see there turn your NEET 2025 dream into a reality with the NEET rank improvement scheme. We have in various salient features here, 480 plus live classes with complete NEET syllabus, and downloadable notes, class recordings and DPPs as well, and 5,000 topic wise recorded videos by India's top NEET level faculties that are displayed here, and chapter wise previous year questions with along with video solutions, questions and discuss solutions video आपका मिल जाएगा, and weekend test and monthly test, cyclic test, everything is available for your betterment, and tracking is also there, how you are preparing, and periodic counseling will be there, and you can get doubt resolution कभी भी कर सकते हैं 24/7, and 30 NEET Achiever series printed books भी है. So these are prepared by the eminent faculties from Infinity Learn Contented team, and parent mentor meetings with progression and discussions. Okay, yes, Ashik, hello, good afternoon. And you can see the numbers with Infinity Learn. There are 9 students who scored 720 out of 720 All India Open category. Proud to say that is given by Infinity Learn. And below 100 there are 45 students and scored 700 plus. Can you believe it? It is 132 students. Mind it. So that you try to do something. So a time pass करने का drop न मत लेना. So अच्छा तरफ सोचो, अच्छा तरफ अभ्यास करो, आपका अच्छा होगा. And these programs are very meticulously designed, and batch starts from 3rd August for NEET Dropper, and you have various programs here. NEET 2025 self-study program. In that self-study program you will get all the features that I disclosed. It is just for 9,000 rupees. एक बार सोचना, and you can take a trial of it, and you can decide whether you can do or not. And even in many batches, myself is actively taking a couple of batches there. Logavanagam, happy afternoon. How are you? Saturday, you are not seen in the half of the class. Do you have an internet issue? You have an internet issue. Okay. So maybe in the next session I can give you kind of coupon code and all, so that you can enroll for the better price as well, right? So without any delay we will go into the thermodynamics, right? Logavanayagam, fine? I asked you something. Ashik. Okay. So let's talk about Anamani is not there today, and what about Richa Sharma, and Abhinav will come in a short while. And Hitman also will come. Rohit, huh? Very good. I am very happy to interact with you guys with YouTube platform. So in the YouTube platform, it is not like a radio transitions, right? So when the session is going on, student is continuously interacting with me, I am interacting with the students whenever the things goes good. Thanks when the concept is being discussed, I am discussing the doubts that is asked in the live session. So today we will start with thermodynamics without delay, and we will see the more and more content. So part 2 of thermodynamics, that is about PV work से शुरू करेंगे, pressure volume work. In thermodynamics, heat and work are interconvertible, right? When the heat and work, so what kind of work? It can be mechanical work or it can be electrical work. So any work. So in terms of quantifying the magnitude in thermodynamics, conventionally said with PV work. So what is a PV work? That is pressure volume work. When the gas is enclosed in a cylinder with a frictionless massless piston. So when the gas is expanded, how much work is done by the gas against to external pressure, and when the external pressure is applied, the gas is compressed, how much pressure is applied. So the work is we are doing on the gas, so that piston is coming down. When our expansion work is done by the gas means by the system. When the compression is happening, work is done on the system. Okay, so let's see here, the consider a cylinder fitted with a frictionless massless piston enclosed in n mole of an ideal gas. let external force F pushes the piston inside the producing displacement of a piston. So that what happened when the piston is expanded like this, there is a small change in the volume. So that is a dV, and that work is given as dW is equal to F dot dx, that is this is what you call it is dx. Okay, Hitman. Okay, Jivan Solanki, fine. Good afternoon, Spencer. I forgot your name. So very good concepts we are discussing. Okay, you can interact in the chat box. So swarming ma kam karo. Okay, Hitman. Good afternoon, Sir G. Very good afternoon, Hitman. And good afternoon, Jivan Solanki. Very good. And let us focus here the work done. So thermodynamics little bit logic oriented. Let me have a chance to discuss about how the logics can be unfolded in a simpler way. Okay, so pressure is equal to force upon area. Force is equal to pressure into area. So that W is equal to PA dx. Okay, dx is a small change in the volume, and volume is equal to V2 minus V1, you can say L minus X, because this is the length of the piston that is moved, and dV is equal to minus A dx, dW is equal to P dV. Yes, dW is going to be P dV. So this is the formula where from reversible and irreversible process you can go it, right? So we'll see why minus is given. Work can be negative, work can be positive. If the piston is rising, work is done by the system, W is going to be negative quantity. If the piston is compressed, so work is done on the system, so that W is going to be positive. That's good, fine. So let's talk about more details. So during expansion, dV is positive and hence sign of the work is negative. That's very important point. So when you solve certain questions from the NEET examination, you just focus on the sign conversion. Okay, interesting, easy. It's easy only. And work done by the system, and negative sign is representing decrease in energy content of the system. During the compression, the sign dV is positive and the work done is going to be positive. That's very important. Okay, it's very logical. Now let's talk about sign conversions. According to the latest sign conversions, that is not given by me, that is given by IUPAC in chemistry. Okay, yes. Chale gaya, nahi chale. So focus on the concept, Hitman. I told you when you come here, I told you, right? So when you just talk about IUPAC conversions, physics and chemistry follows a different sign conversion here as compared to the physics. So that's a different debating matter. So work is taken negative if it is done by the system, since energy of the system is decreased, that is expansion of a gas, W is going to be negative. So it's very simple. It is a long conversation. In one word I am giving you the best sign conversion version. Yes. And let's talk about expansion. When work is taken positive, if it is done on the system, since energy of the system is increased, W is going to be positive. Therefore, we can say, so a question, find the work done in each case. A, when 1 mole of an ideal gas in 10 liter container at 1 atm is allowed to enter in evacuated bulb capacity of 100 liters. What is the answer? And when 1 mole of a gas expands from 1 liter to 5 liter against a constant atmospheric pressure. So ये दोनों करके बताओ. Hitman and student of NEET, okay, and Spencer, Ishita, many students are there. I am expecting you to give the answer for the first one. At least for first one. Second one I'll give. You give the answer for the first one. Let us make this interaction like live class. It should be interactive. Yes, it is Shivans. I forgot your name. Shivans. Yes, I forgot. Shivans. Yeah, definitely I'll take a PYQ, that is day after tomorrow. Today we'll talk about up to second law of thermodynamics. tomorrow total thermochemistry, and day after tomorrow total PYQ and multiple choice questions on thermodynamics, just we done in general organic chemistry on Saturday. Remember, general organic chemistry Saturday, that day we discussed more than 60 questions about all NEET level standard questions, right? Are you ready for that? Day after tomorrow we'll discuss. Is that fine? Shivans, be regular. Shivans, be regular. I just want to give the answer. I want you to give the answer for the A. Question A. What is the answer for this? Expecting, do something and give. Yes, yes, of course. That's fine. Okay. Answer, make it fast. Easy, easy, easy. The simple way of using this particular question, W is equal to minus P external delta V. We derived this also. Who will give the answer? Make it fast. I want the answer in a quick succession, because in the NEET examination the time is also important parameter to give the correct rating to you guys. Okay, now let us go ahead with the actual answer. You want a couple of minutes of time or what? No, time is so precious. Time is so precious, my dear students. Come on. Hitman, बिल्कुल सही बात है. आपका आंसर क्या होगा इसमें? जल्दी फटाफट. Okay, it is against. Yes, it is. Shivans, you have given 1 by 22.4 into 31. Okay, so let's talk about W is equal to minus P delta V. But since the gas enters into the vacuum, P delta V, P external is going to be 0. है ना? So that W is going to be minus P, value is 0, and delta V is going to be from anywhere to anywhere. Okay, it is going to be 0. W is going to be 0 because it is against to external pressure. 0 है इसका. So that is what you call it as free expansion. That is what you call it as a free expansion. Har bar. So whenever vacuum comes, take the work done is going to be 0. That is a simple way. So you don't solve it. Simple. Yes, 1 atmosphere is equal to 101.3 joules. Shivans, it's correct. And let's talk about the second one. When W is equal to minus P delta V, so that it is against to 1 liter to 5 liter against a constant atmospheric pressure, so that P external is going to be 1 atm. Whenever it is 1 atm, 5 minus 1, that is going to be minus 4 liter atmosphere. As Shivans said, you can see 1 liter atmosphere is equal to 101.4 joules. Okay, 101.4, 101.3 doesn't matter. दोनों एक ही है. Okay, so that you can say yes. So it is going to be minus 4 into 101.3 joules. So you check the answer with NEET multiple choice question, can be given this or can be given this. Yes, good afternoon. Good afternoon to see the students over here. Very good. Be regular in the class. Shivans, Spencer and Hitman, Ishita, all students, fine? Yes. Now let's talk about one more question. It is a very important question. Spencer, you are asking about you are asking about PYQs. I don't even remember exact year, but it was a PYQ. It is related to NCERT textbook, and let us do what is that. Find the work done when 18 milliliters of water is getting evaporated at 373 Kelvin, so that it is boiling, right? And in the open vessel, assume the ideal gas behavior of water vapor. It is really cheating here. Water vapor is a water is a liquid, it is evaporating. So there is no gas that behaves ideally that we studied in the gaseous state. Here we are assuming water vapor as an ideal behavior. How it is possible? Definitely water vapor do not behave like an ideal gas. But assume it, use it. Okay, how can you do this? Spencer, कर सकते हैं? मान लो ये आइडियल बिहेवियर के जैसे है. So that 18 milliliters of water, so 18 milliliters का मतलब 18 grams का है ना. So number of moles 18 grams upon 18 is equal to 1 mole of the water vapor. Mind it, 1 mole of the water vapor. PV is equal to nRT. इस्तेमाल करो. PV is equal to nRT. PV is equal to 1 into 0.0821 into 373. आपका PV मिलेगा 30 liters, V मिलेगा 30 liters, है ना. Volume in 1 liter and volume in liters and T in Kelvin. P is equal to 1 atm. So that ये मान लो वैल्यू 1 होगा क्योंकि at atmospheric pressure यही से हो ना. Yes, that's good. Okay, so W is equal to minus P delta V minus 1. P मान लो 1 का है, 30 volume of the gas. So ये minus 1 का okay into 30. So volume is going to be minus 30 atm, है ना. So it is minus 30 liter atmosphere. This is the where Shivans, this is the where students go wrong. This is the where student gone wrong. Shivans is given 30 liter, लेकिन हमारा आंसर minus 30 liter बन गया. सेम आंसर्स नीट एग्जामिनेशन में ऐसे ट्रैप भी मिलेगा आपको. नीट एग्जामिनेशन में ऐसा ए बी सी डी ऑप्शंस में एक ऑप्शन में +30 देंगे और दूसरा ऑप्शन में -30 देंगे. सो दैट यू विल बी जस्ट कंफ्यूज्ड बाय लुकिंग एट द ऑप्शंस, है ना. आई आर ए रैंकर बेटा पक्का. सो डेफिनेटली यू विल बी ज्वाइनिंग इन योर एम्स एग्जामिनेशन. हाँ, so that work is equal to minus 30 liters into 101.3 joules. So answer ऐसे तरह देना, आंसर ऐसे तरह देना. ऑप्शन के हिसाब से आप आंसर पकड़ना. Yes. Great. Nice. Have any doubts in this? Great. Yeah, the same thing you can do it now. Same thing you can show. A sample of gas expands isothermally from 10 liter to 20 liter against a pressure of 2 atm. Calculate the work done. So that you can use that formula. Yes, you can. Okay. 10 minus 20 minus 10 na V2 my delta V is going to be 10 only. So P external is equal to 2. 2 into 10 is equal to 20 liter atmosphere. Your answer is correct. Agreed. Now let us go ahead with some more analytical questions. Yeah, definitely we'll do, Spencer. We have 2 more lengthy marathon questions in this particular session. Get ready for that. Now let's talk some more concept and we'll go again with the questions. डॉक्टर ऑंगटन लिन, आशुतोष परिहार, काउंसलिंग कब स्टार्ट होगा? काउंसलिंग तुरंत स्टार्ट होगा इन बाय द एंड ऑफ अगस्त. काउंसलिंग भी होगा. ओके, मेन कोर्स ऑफ द काउंसलिंग विल बी इन द मंथ ऑफ अगस्त. हाय डॉक्टर ऑंगटन लिन, यू आर फ्रॉम चाइना. Okay, so what I feel, dear students, when you enter in the sessions, when I feel many students with different weird names, okay, so even I really enjoy those names. Okay, come on, let us go ahead with heat. Heat is defined as the amount of energy which flows between a system and surrounding because of the temperature difference. Whenever you see it is a hotter body and it is a colder body, so let us say T2 is greater than T1. So when they are in a physical contact together, so there is something, there is some energy, heat moves from hotter body to colder body. The quantity of energy that transferred from hotter body to colder body when they are in contact, that is called heat, and that transfer phenomena is called as a thermodynamic operation. In that thermodynamics, not heat always flow from high temperature to low temperature. That is a universal fact, and which believes the thermodynamics there only. This cannot be reversed. This cannot be reversed unless some work is done. So the heat cannot go from the colder body to hotter body unless some external work is done. That is what is happening in the refrigerator and air conditions. So today we are experiencing all types of gadgets and machinery, and everything should follow the laws of thermodynamics, right? So this is the surroundings, and this is the surroundings of a system. When the heat goes in, its quantity is supposed to be positive, that is the convention. When the heat is coming out of the system to the surroundings, the heat quantity is taken as a negative, and work is done by the system on the surroundings, the work is done by the system, work is negative. And when the work is done on the system from the surroundings, the work is going to be taken as a positive. This is the rule we have to follow in thermodynamics of chemistry. Fine. Okay, कहाँ गए थे तू? Okay, Shivans, let's go ahead. Any doubts here? Ashutosh Parihar. Okay, let's go ahead with the difference between heat and the work. दोनों एक ही है, magnitude. When a gas is supplied some heat, its molecules move faster, क्योंकि heat का वजह से kinetic energy इसका बढ़ गया, and faster and with greater randomness is different directions are seen. So gas molecules are in the random chaotic motion, and work is done on the same system. Gas molecules are compressed, move initially in a direction of a force, they are getting condensed, that is called compression. And so heat is random from the energy, while work is organized from the energy. So work is organized, heat is just, it's a random, right? Yes. हाँ, drop ले सकते हैं तो ये अच्छा बात है बेटा. That's what I explained. So those students, again I am telling you, my dear students, you want to take a drop, I have a session, I have a slide before you enter into the session here. These are the students we can see. These are the student you can see who got 310, got 661, 350 marks बढ़ गया आश्रित का, है ना? Yes, it is. And you can see Akhil Verma 345 marks बढ़ गया. शिवांश, सच बात है, मैं खुद पढ़ाई किया इन लोगों को. ओके, हिमाज्योति 342 मार्क्स बढ़ गया, एंड सत्यनारायण 320 मार्क्स बढ़ गया. Or many students are like this, and I am expecting you will be in the same slides for the next year. I am going to take the sessions in the same studio for your next upcoming batches. है ना बेटा? So let's go ahead with the current context. Yes, difference between heat and energy, right? Yes. Okay, so let's see the internal energy and the first law of thermodynamics. We discussed about the first law of thermodynamics. What is the first law of thermodynamics, beta? What is the first law of thermodynamics? Shivans, come on. What is the first law of thermodynamics? Abhinav? Rohit? So internal energy. So the first law of thermodynamics based on experience, just experience that energy can neither be created nor destroyed if both the system and the surroundings are taken into the account. Okay, यूनिवर्स में क्या होता है, सिर्फ सिस्टम एंड सराउंडिंग्स का है ना. हाँ, yeah. Now we'll see. Suppose a block of mass m is moving with a gravitational field of velocity v. It is a physics का है, chemistry PV work फिर भी. And the total energy of the blocks in the earth frame is referenced to as E is equal to K plus V plus U. K is the kinetic energy, V is the potential energy, U is the internal energy. So this is the total energy of the system. है ना? Aha, right. So if a system is present in a particular thermodynamic state A and a fixed amount of internal energy UA, suppose a system is taken into the state A to B, then the process Q is absorbed and W work is done on the system. Okay, thus the B total energy can be given as delta U is equal to Q plus W. Kaise? How? This is actually mathematical form of first law of thermodynamics. Energy can neither be created nor be destroyed, only altered into one form to another form. Or else, if some quantity of some energy in one form is disappeared, the same quantity of another form of energy should appear. है ना शिवांश, है ना? और आप ऐसे भी बोल सकते हैं, अगर some quantity of energy is disappeared, the same magnitude of the work should be performed by the system, right? So here energy conservation is important, right? So you don't have to worry. First law of thermodynamics cannot heat, the energy cannot be created or destroyed. Second law of thermodynamics, for spontaneous process, the entropy of the universe increases. फिर भी yes. Now जीरो तला क्या बोल रहे हैं, जीरो तला क्या बोल रहे हैं, एंड थर्ड लॉ भी क्या बोल रहे हैं, फटाफट बोलो, फटाफट बोलो. Yes, third law of thermodynamics, a perfect crystal has 0 Kelvin, has 0 entropy, perfect. At third law, kinetic energy is going to be seized and the volume becomes 0 for an ideal gas, and the entropy of the crystal is 0 at 0 Kelvin. And zeroth law, zeroth law, zeroth law, waiting for zeroth law. You are typing, I really appreciate it. When three systems are A and B and A and C are in thermal equilibrium, you can say B and C are also in thermal equilibrium. It talks about the thermal equilibrium. I just want to say A and B and C. If the A and B are in thermal equilibrium, A and C are in thermal equilibrium, you can say B and C are also in thermal equilibrium. That is called zeroth law. Yes, it is. Now happy? So whenever you just give some input, I am going to give its extended one. Really happy to say that. Okay, come on. So I just want to say about the explanation. छोड़ दो. That is about zeroth law. Now you can see a system, initially it has U1 internal energy. It is internally energy U1. Let us say some amount of Q is supplied and some amount of work is done, so that the system is going to change into U2. Simple thermodynamics. So U2 is going to be U1 प्लस ये वाला भी ऐड करने के बाद U2 बन गया, सो दैट इट इज Q प्लस W, है ना? यस एग्जैक्टली. अरे U1 इस तरफ ले लो, सो U2 माइनस U1 इज इक्वल टू Q प्लस W. सो U2 माइनस U1 इज इक्वल टू डेल्टा U, Q प्लस और माइनस W. मान लो W can be negative or positive, work done by the system or work done on the system. है ना बेटा? है ना? Clear? It is very simple. This is the mathematical version of the first law of thermodynamics. And it's a question. You can see. So this is an illustration. A system is taken from a state I to the state F. I stands for initial and F stands for final. Okay, and I am going to give you the figure as well. This is I and F. Okay, and along the path A I A F, I A F दिखाई दे रहा है क्या? दिखाई दे रहा है? ना. You just follow here, Shivans follow here, and if it goes IAF, dear students, now calculate. You are asked to calculate W along the path IBF, and work done. If work done is minus 13 calorie for the curved path Fi, and what is delta Q for this path, and taking UI 10 kilocalories, UF यहाँ से 10 था, and if UB 22 kilocalories, and Q for the process I and for the process BF. So you just see analogical. So it is analytical one. There are 4 numerical suspenses. You can see there are 4 numericals. So 4 numericals along with the detailed description I just want to show. Hope you understand this question first. Clear? So question A, B, C, D. So let's solve A here. So for path IAF, I, A, and it is for F. Right, beta? So for IAF, so Q is equal to 50 calories, W is equal to 20 calories. So delta U is equal to Q minus W, first law of thermodynamics का हिसाब से. So that is 50 minus 20, हमको बच गया 30 kilocalories. So the difference is going to be 30. So as internal energy change is a state function, delta U will be the same for any path I to F. Simple na? I to F. Clear? That's good. You see how logic question this is. It's a logical question. So Nihal, who are the other students there? Ishita, Abhinav, Rohit, Annamani, come on. Where are they? Yes, some glitch in the chat box. Come on, let's go ahead with this is your student. It is a relate ka third law of acceleration. हाँ ना ऐसा नहीं. Okay, come on. Next, let's talk about the B. Path IBF ka. Right. So in this path IBF, delta W is equal to Q minus W, and W is equal to 36 minus UF minus UI. Okay, initial one. 36 minus the difference is going to be 30. ये पिछले क्वेश्चन से निकला 30, ये 30 यहाँ पर डाला, so that is your 30. So 36 से 30 subtract करने तो आपको मिलेगा 6 calories. Okay, so when the question is given in the calories and operate the question in calories, when the question is operated in later atmosphere, operate in later atmosphere, and if it is asked in joules, you just convert later atmosphere into joules by multiplying with 101.3 joules. 1 liter atmosphere is equal to 101 joules, right? Very good. Now let's talk about path Fi. Path F से I तक है. Path F से I तक है. So that delta Q is equal to delta U plus W. Delta U is equal to UI minus UF, that is equal to 30. We already got it, plus W. Now that is given as minus 43 calories. Minus 43 calories. Got it? Okay, right. So ये and ये से B करना. Now थोड़ा सा आगे बढ़ो, और एक क्वेश्चन है C. So UF minus UI, that is 30 kilocalories, we know it, and UF is equal to UI plus 30. So UI, that is make into 40, you are going to get 40 kilocalories. Okay. Now let's talk about the process I to B. Process I to B. Yes, it is a isobaric process. समझे? प्रेशर कांस्टेंट कहना, प्रेशर कांस्टेंट है, जब प्रेशर कांस्टेंट होता है आइसोबारिक प्रोसेस बनेगा, है ना. सो Q इज इक्वल टू W plus W, so WU plus W, internal energy change plus work done, so that UB minus U plus work done in the IBF process. So work done is IBF process, so that is going to be minus 22 minus 10 all plus 6 is equal to 32 minus, yes, 12 minus 6, इसका प्लस होगा ना. Yes, it is 18 calories. Yes, Ishita. Yes, correct. Just see, sign conversion makes it. Sign conversion makes it. Okay. Now process BF. In the process BF, इस तरफ जाना. So it is isochoric process. Volume is constant. In the isochoric process, Q is equal to W delta U plus W. So the difference is going to be 40. We got it. So from the 40 plus W, because work done is 0, because delta V is going to be 0. So that the difference here 40 minus 22 फिर भी 18 kilocalories मिल गया. So you can see the entire numerical looks complicated. When the entire numerical looks complicated, you take the piece of the analysis. When you take the piece of the analysis, it is a simple 2 steps. Simple 2 steps. It is not a 3 step, it is 2 step, right? How? Now isothermal process. Let us apply thermodynamics first law. Thermodynamics first law. Delta W delta U is equal to Q plus W. Let us apply for this isothermal process, isobaric process, isochoric process, adiabatic process, like that. In isothermal process, what is say dT is equal to 0 and also du is equal to 0. So that 0 is equal to Q plus W. So minus Q is equal to W. That's it. That is the version of this isothermal process. So du is equal to 0. So from the first law, del Q is equal to W. So this is what is called as isothermal process. The isothermal process में expansion भी कर सकते हैं and compression भी कर सकते हैं, है ना? Expansion. So isothermal expansion. So isothermal expansion system doing work, W is going to be negative. Both Q and W are positive quantities. If the gas expands, it takes heat from the heat reservoir and does positive work. Okay. Now the process takes place slowly. As a process, the piston reduces, the gas tries to expand. So because P external is less than pressure of the gas, है ना? So in expansion tends to cool down, but the heat reservoir gets input and the key temperature constant. So it's an isothermal process. Okay, dt is equal to 0. Simple, phenomenal. Okay. Now in the compression, what happens? It is going to be P external is greater than P gas. P gas. Now in the same way the reverse operation takes place. You can see here, my dear students, expansion, the work done is going to be area of the shaded part. In that you can see the graph direction is in this way. Okay. In the compression, the work done is going to be area of the shaded part and this is going to be the direction. Understand? This is going to be the direction. Clear? Yeah. So this is how you have to start, and let us talk about the adiabatic also. Just a minute. Ishita, hope you are finding these classes are helpful. Ishita, you are finding these classes are absolutely helpful to for you preparing NEET examination. Huh. That's good. Then a thumbs up. Let's talk about adiabatic process. Adiabatic process, dq is going to be zero, heat neither be absorbed nor be given out. So in adiabatic process, no heat enters or leaves the system. Such a situation achieved by the heavily insulated system from the first law of thermodynamics, U is equal to delta U plus W. Okay. So that you can say for adiabatic process dq is equal to 0, du plus dw is equal to 0, and it is going to be in this gas process PV power gamma is equal to constant. Man lo, this is very important for adiabatic. What is gamma there? Gamma is the ratio between Cp and Cv. Cv is the molar heat capacity at constant volume and Cp is the molar heat capacity at constant pressure. I will tell you in the next slides, and this is constant, so that P1 V1 of power gamma is equal to P2 V2 power gamma. So if this is the case, you can see the adiabatic curve PV diagram is much steeper than that of a isothermal curve. So that you can say when it is taken as PV, you can say this is your pressure is constant. When this pressure is constant, you can say, simple thing I just want to say, pressure is constant. This process you call it as isobaric process. Mind it. If the process goes like this is what you call it as isochoric. मैं क्या बोलना चाहता हूं यहाँ पर, you can see hyperbolic graphs, there are this is called isothermal and this is adiabatic. What I mean to say, the nature of curve for isothermal and adiabatic both are same, but adiabatic process is little steeper. Minded, this point is very important. Okay. So it will be a question in your NEET examination like what is the nature kind like this. A, B, C, D. When the PV graphs is given in the NEET examination, you can get a question, yes or no? What is the nature of the curve about C? Ishita, what is the nature of the curve C? What process is that? Ishita, come on, what process is that? What process is that? C hai na? It is adiabatic process. Is that fine? Like that you need to identify, and the loss of the speed causes the fall in the temperature, the gas goes positive work and internal energy decreases. Network problem, okay, internal energy decreases, okay, that is about the expansion. When you see delta U plus W is equal to 0, I am talking about adiabatic expansion beta, and it is going to be delta U is negative. Why? Internal energy decrease, therefore delta U is negative. Delta U is negative. That is the understanding point there. And internal energy of the gas is being converted into the work done by the system. Okay. Now the reverse adiabatic compression. In the adiabatic compression, you can see compression, the work should be in this way, right? That graph should be in this way. Now the same, and delta U is going to be positive, work is negative, okay, for adiabatic. Now, can you say what type of process is this, Ishita? What type of process is this? Pressure and volume. When the process is going like this, volume is constant, na? Isochoric process. This is isochoric process. A process in which the volume remain constant is known as isochoric process. And for isochoric process, ideal gas taken in a container with residue wall, so that the expansion compression occurs. Neither expansion compression occurs. Volume is constant. The volume is constant, no heat is absorbed, no heat is gained, and no work is done. Okay, W is equal to minus P delta V. Delta V is going to be 0 there. Yes. Now it is going to be 0. Work done is going to be 0. Now Q is equal to W. Q is equal to W. So if heat is given to the gas, the temperature and the pressure rise and the internal energy rises. Del Q and Q are both positive. Heat is given. The reverse, the heat is taken out. The process is going to be reversed. है ना, यहाँ पर पॉजिटिव होगा, यहाँ पर नेगेटिव होगा बेटा. Simple, make it simple. Okay, now what is this? Heat is by a source. I just want to give. So this process is called isobaric process. Why isobaric process? Piston is raising up to when the heat is given by the source, so that the pressure constant, pressure increases. So make it pressure, the piston is raised. The shaded part. And in that case, Q is equal to U plus W. And also for the compression, this is the work done area of the shaded part. Q is equal to U plus W. Again, only the causing negative work, only the causing positive work, so that expansion and compression lies like that. Okay. So let's talk about the microscopic nature of the first law of thermodynamics. I mean to say, don't go and see the first law of thermodynamics under microscope, just to see the microscopic analysis of the first law of thermodynamics, my dear students, here. So the internal energy of the gas confined in a container is defined relative to coordinate system fixed to the container. So viewed at a microscopic level, the internal energy can take on a number of forms. So how many number of forms internal energy is studied? So first law of thermodynamics is connected to internal energy. So this internal energy is connected to enthalpy. Richa, happy to see you. Happy to see you. More than 100 times I asked you. So even Ishita is also clueless that where did you go? College started. Good afternoon. Good afternoon. Where did you go? Not seen. So at least watch the recordings. Watch the recordings. Okay. So let's talk about the first law of thermodynamics. It is connected to internal energy and more about enthalpy. आगे आपको मिलेगा. स्कूल स्टार्ट हो गया, लेकिन second law of thermodynamics, it talks about entropy. Mind it. Okay? Yes. हाँ शिवांश, कहाँ गए तू? कहाँ गया? Let's talk about how the internal energy is viewed in various cases. First, the kinetic energy of the molecules, the potential energy of the constituent of the system, and the internal energy is stored in the form of chemical bonds that can be released through a chemical relation when the bond is broken. And the total of all the forms of energy of a system of interest is given as U, and it is called as internal energy. So that internal energy is equal to transitional energy, sum of the rotational, sum of the vibrational, intermolecular, electronic, and relativistic, and what not. जितना एनर्जी फॉर्म्स होगा उतना एनर्जी फॉर्म्स का ऐड करना. Yes, 2 number. Okay, so let's see internal energy and its application. Let us talk about enthalpy. Why we need enthalpy? Enthalpy is required. You've gone old. Okay, what I mean to say, energy, internal energy is the energy, sum of all energies in the system. So, but when you talk about the thermodynamics, we will talk about the various forms. So, we need another thermodynamic terminology because all the processes that are taking place in the on the globe, you can say, it is against to the constant external pressure. So, internal energy takes a constant volume is a consideration, but we need one more thermodynamic property which talks about the energy at constant pressure, that is nothing but enthalpy. है ना Selvi? Thermodynamics, we already in the second session middle. So, Selvi, you just watch the first session, you will understand what is thermodynamics. Yeah, I am 22. Okay. Okay, so leave the other stuff. Okay, Selvi, come on. Thermodynamics is a branch of science which discuss about, which deals with the heat transfer during a process. Okay, Kishan. Okay, Kishan, you understand? Kishan, you understand? Right. So let's talk about enthalpy. Chemical reactions are generally carried out at constant pressure of the atmospheric pressure. So it has been found it useful define a new state of thermodynamic function, that is enthalpy H. Okay, so COIPL, so intermediate का और 11th standard का syllabus चलते रहता है, 11th standard का syllabus का है. So let's go ahead with what is enthalpy. So the enthalpy discuss about the heat content of a system at constant pressure. At this we can say, we know that enthalpy is nothing but internal energy plus PV work done by the definition. So enthalpy is internal energy plus PV work done, right? Yes. So in that, delta H is equal to delta U plus P delta V. You can say why delta P delta V नहीं दिया, क्योंकि ये कांस्टेंट प्रेशर का है, सो दैट ये कांस्टेंट होता है, सो दैट देयर इज नो चेंज हियर, राइट? ओके, सो लेट्स डिस्कस अबाउट एंथैल्पी एंड इट्स एप्लीकेशंस सम फर्दर मोर, है ना? लेट्स टॉक अबाउट हीट एक्सचेंज at constant volume at constant pressure. It heat at constant pressure, heat at constant volume, QP and QV respectively. For isochoric process, dV is equal to 0. So when dV is equal to 0, you can see, my dear students, for isochoric process, dV is equal to 0 in a system involving PV work done, so that delta U is equal to QV. That is for isochoric process. You can also go with the result is valid for the substances under isochoric conditions when only PV work is involved. You want to apply the same concept in the electrical work, you can't do it. Okay, Kishan? Who is talking in Telugu? Sylvie? Kishan, who is talking in Telugu? So you want me to teach in Tamil or what? Even I don't know Tamil. Okay, come on. And delta H is equal to QP. Yes. Okay. So also from the previous article it is clear that, okay. So now that is the result is valid only substance involving isobaric process. In the isobaric process, dP is equal to 0, only one PV work is involved, hence heat exchange is constant, pressure and volume was important. They are definite quantities. They are definite quantities. It is English only. Relation between the heat, work, temperature and energy. Very good. I'll give it. I'll give it. Okay. Okay. So heat capacity. So the heat capacity of a system may be defined as the amount of heat required to raise the temperature of a system by 1 degree. It could be It could be for a gram of substance, it could be for a mole of substance. So the heat that is need to be supplied to raise the temperature by 1 degree centigrade, that could be specific heat capacity. So that specific heat capacity is the heat that is required to raise the temperature of 1 gram of substance by 1 degree. Okay, let us say temperature is 30 degrees, 31 बढ़ने के लिए कितना heat supply करना पड़ता है. So if that is for 1 mole, if del Q is the smallest quantity of heat added to the system, let the temperature of the system raised by dt, then the heat capacity of the system is C, and it is given by C is equal to dq by dt, that is called heat capacity. So joule Kelvin inverse, that unit is joule Kelvin inverse is the unit. Okay, that's good, nice. Here download Infinity Learn app and test preps also, you can get more. कोई problem नहीं, कोई problem नहीं. So focus on the concept, better focus on the concept. Now in case of the gases we have two types, heat capacity is heat capacity at constant volume or heat capacity at constant pressure. Heat capacity at constant volume is called Cv, heat capacity at constant pressure, that is called Cp for a mole of the gas. So that is called molar heat capacity. So specific heat capacity for 1 gram of the substance and molar heat of capacity for 1 mole of the substance. Children, let's talk here. So heat capacity at constant volume. So for 1 mole of the gas, the amount of heat that need to be supplied at constant volume to raise by 1 degree. So Cv is equal to dQv by dt, and that is for from first law of thermodynamics, du is equal to dq minus dw. Yes, I will translate later. Focus on the concept. Thermodynamics is not simple concept. I am doing a lot best to make it simple. So you are engaging in the chart box like the other stuff, you focus the chart box for the academic stuff. My keyboard does not work, that you can, so the answer for your answer. Okay, leave it, come on. So आपको मिल रहे हैं dW is equal to pdV, and at constant volume du is equal to dq minus pdV. So du is equal to dqv. I just want to say heat capacity at constant volume is given as Cv is equal to du by dt at a constant volume. Okay, so if at constant pressure आपका Cp मिलेगा, so that is called, that is Cp, heat capacity at constant pressure Cp. Okay, that is called Cp. That Cp is equal to dH by dt. So if you use at constant pressure enthalpy, if you use at constant volume, that is internal energy. Got it? So that is Cv, it may be defined as the rate of change in internal energy with the temperature at constant volume, that is at constant volume, and it is the rate of change of enthalpy with the temperature at constant pressure, that is the Cp. And what is the relation between Cp and Cv? So Cp and Cv, for 1 mole of a gas, always Cp is greater than Cv at a given conditions. And the relation between this you might have seen in the physics. So the relation dH is equal to Cp delta T. It is valid for any substance other than ideal gas only in isobaric process. Whereas du is equal to Cv dt, this is valid only at constant volume process, that is called isochoric process, where dV is equal to 0, यहाँ पर dP is equal to 0 है ना, हाँ ये भी कर सकते हैं. Now you can see, ये पहचान है आपको, ये टेबल. So degree of freedom you can say n, and Cv is equal to n by 2 r, Cp is equal to n by 2 plus 1 r, and gamma is equal to Cp minus Cv. And I just want to say Cp minus Cv is equal to r. For monoatomic gases, gamma is equal to 5 by 3. For diatomic gases, gamma is equal to 7 by 5. For triatomic gases, gamma is equal to 9 by 7. And it is for any polyatomic gases. When you use the degree of freedom for monoatomic gases 3, diatomic gases 5, and triatomic gases 7, this particular table can be useful for you guys even for thermodynamics and gases state also. And not only here, you can do it in many ways, and let us go ahead with some more details. Calculate the work done when 1 mole of zinc dissolves in hydrochloric acid at 273 Kelvin in an open beaker in a closed beaker at 300 Kelvin, and this is very important for NEET type of analytical questions. Ready to do this? Spencer's requesting me to provide some questions. So first one you do it, second one I'll do it. Are you ready? Start. I want to see how you give the answer. Shivansh, Kishan. Shivansh and Kishan. Ishitam, Nihal. I am just calling every student who is present in the class, giving 1 minute of time. Who will give the answer? फटाफट बोलना. एंड चार्ट बॉक्स में आपका आंसर देखना चाहता हूं मैं. Yes. Shivansh, answer. Answer. Yes. Make it fast, na. Make it fast. Okay, from the 1 mole of zinc, the number of moles of hydrogen evolved is 1. Why? Because zinc plus 2 HCl gives rise zinc chloride and hydrogen gas. So ये 1 mole होगा तो ये भी 1 mole होगा ना. So it is given as 1 mole of zinc, number of moles of hydrogen is going to be 1, है ना. So that hence the volume of hydrogen evolved 1 mole of is equal to 22.4 liters when the pressure is 1 and temperature is 273. लेकिन W is equal to minus P delta V, so that is going to be minus 1 into 22.4 liter atmosphere, and it is minus 22.4 into 101.3 joules. आपका आंसर यही मिलेगा. समझे? Very simple. That is going to be minus 2271.1. If it is in a closed, beaker 300 Kelvin, ये थोड़ा सा काम करना. कैसे कर सकते? Sir, for a closed system, P external is equal to 0, therefore W is equal to 0. I asked you to do it when the closed work is delta V is going to be 0, na? Right. And reversible adiabatic process एक थोड़ा important है. Reversible adiabatic process, ये process थोड़ा सा high end के लिए जाना है. So ये process little more edge we are taking. Actually adiabatic process का वजह से questions आना है बहुत कम मिलेगा. But process ये competitive world में सीखना important है. Now in an adiabatic process, no loss or gain of heat is saying dq is equal to 0. From the first law, dq is equal to du plus dw, right? Now from that dq is equal to 0 का वजह से du is equal to minus dw. So from there you can say du is equal to cv dt, because it is an adiabatic process, constant volume CVDT, and from there you can say, or that can be given as T1 upon T2 is equal to V2 upon V1 to the power gamma minus 1, or T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1 is equal to constant. For an ideal gas, P1 V1 by T1 is equal to P2 V2 by T2. Now T1 upon T2 is equal to P1 V1 upon P2 V2. So from there you can say, from the equation, this equation you can get it, P1 V1 power gamma is equal to P2 V2 power gamma is equal to constant. That's it. That's clear, pretty clear, right? Pretty clear. Now for polytropic process, it's important terminology is only. For polytropic process, a process described by PV to the power n is equal to C is constant is called polytropic process, where n is a real number. Okay, PV to the power n is equal to constant, nothing. Okay, work done for polytropic process is given as सिर्फ आपका ये फार्मूला का वजह से P2 V2 माइनस P1 V1 upon n minus 1. N is a real number. Okay, n is a real number. समझ में? Okay, समझ में रह गया? Yes. Shivansh, fine. Next. Now let's talk about the relations. Very important relations I am giving you. Students, we can see for a isothermal process, work done is equal to reversible, W is equal to 2.303 nRT log V2 upon V1, and then heat is going to be Q is equal to 2.303 nRT log V2 upon V1. And adiabatic process, we are just seen W is equal to P1 V1 minus P2 V2 upon gamma minus 1. What is gamma? Ratio between Cp and Cv. टेबल भी दिया आपको, है ना? And is equal to nRT. PV is equal to nRT के वजह से nRT nt of T1 minus T2 upon gamma minus 1. Here heat exchange is going to be 0 because it is an adiabatic process. And isochoric process, dV is equal to 0. Yes, dV is equal to 0. So work done बिल्कुल होता ही नहीं. W is equal to 0. Q is equal to NCV delta T. Use definition of CV यहाँ पर निकलेगा. Molar heat capacity at constant volume. That is CV here. हाँ, yes सुरेश कुमार. Log के वैल्यू निकले में प्रॉब्लम होता है. So log values you can be done in a simple trick. When equilibrium start होता है ना, then I am going to tell you the logarithms. Till then you just use it as you know it. I am going to discuss 10-15 minutes about the logarithms, है ना? Network issue कोई problem नहीं. And isosoric process, W is equal to 0, del Q is going to be NCV delta T. And for isobaric process, dP, isobaric process, dP is equal to 0, isochoric process, dV is equal to 0, adiabatic process, dQ is equal to 0, isothermal process, dt is equal to 0. So these are the things you need to know. W is equal to, for isobaric process, P delta V, that is equal to P, V2 minus V1, W is equal to nRT, T2 minus T1. So Q is equal to NCP delta T. What is Cp here? What is Cp here? बोलना जल्दी. What is Cp? Heat capacity at constant pressure, है ना? ये वाला Cv, heat constant at constant volume. And this is the beautiful slide for you. Work done कैसा निकलना है? अलग अलग प्रोसेस में एक टेबल बना के आपके सामने रखा. And everybody make a note of this slide and you can get directly use in the NEET examination. मान लो आपका theory question आ सकते हैं, हाँ आपका numerical question भी आ सकते हैं. Yes, it is constant pressure. That's very good. And we are coming to the end of the session here. Dear students, we started again in the first law of thermodynamics. In today's class, we discussed about heat capacities and PV works, PV work in different cases, and first law of thermodynamics in different processes. And we have given heat capacity and constant pressure, heat capacity of constant volume, and also we enter into the enthalpy change, and a formula sheet for the different processes to calculate the work done, to calculate the heat change. Is that fine? Arpana, thank you very much. You are not coming on chat box today. Just thank you बोलने के लिए आया. Okay. So does HC Verma has thermodynamics? Yeah, उसमें है, physics वाला है. Okay, physics thermodynamics physics part का है ना? केमिस्ट्री पार्ट का आपका एनसीईआरटी पकड़ना और मेरा नोट्स और मेरा क्वेश्चंस काफ़ी है. अरे लाइक कर दूंगा मैं. एंड टुमारो वी आर गोइंग टू डायरेक्टली गो इनटू द एंट्रोपी सेकंड लॉ एंड वी डिस्कस अबाउट थर्मोकेमिस्ट्री एंड आल्सो सम क्वेश्चंस इन दैट. एंड डे आफ्टर टुमारो पूरा सारा के सारा आपका क्वेश्चंस PYQs मल्टीपल चॉइस का तैयार है. वेरी गुड. Thank you for so much for today amazing session, and I have given the summary for today's class and plan for tomorrow's class, and I just want to propose, yes, you can crack at least 8 months you have to work on. Definitely you can get it. So please like our sessions and share with your friends and subscribe with these YouTube channels so that you can get the best out of it. Thank you very much. God bless you all. Signing off, Suresh, Faculty of Chemistry from Infinity Lens Studio. Bye bye.